Hi, in the last session, we talked about generics in VHDL and we learned how to create flexible and reusable VHDL code. Now, let's talk about VHDL type conversions. Type conversion is a very important topic as you will be going to use them very widely in your VHDL designs because VHDL is a strongly typed language. And if you do not take care of the data types while assigning them or during the operation, then your VHDL codes will generate errors. So the question is why these type conversions are important in VHDL? Because VHDL is a strongly typed language, means it strictly follows the data type consistency. And this is important while maintaining the integrity and the reliability of your designs. Strongly typed language means that in VHDL, you cannot mix different data types within the same expression. This is not allowed. So your expression must be well defined and predictable. For example, in a single assignment, the data type on the left hand side must match with the data type on the right hand side. When these data types are same, your expression will be executed without any error. However, if there is any discrepancy in the data types or it is not matched, then it can lead to a syntax error. So, in case you wanted to write an expression with mixed data types in VHDL, you will be needing type converters. These type conversions can be used to align the data types so that your assignments and the operations works correctly despite the different data types in the expression. In VHDL, these type conversions can be achieved by using built-in functions and typecasting techniques. Let's consider the most widely used data types first. Each box here in this diagram represents a signal. Black text is a signal name marked with a bold black color, and the white text are the data types. At the top block, we see signal U. This is unsigned type data. On the left, we have signal V, which is STD logic vector type. At the bottom, we have signal S. This is signed data type. And at the right, we have signal I. This is integer type data. First, note that you have to use numeric underscore std package to use these type conversions, as it has already defined some of the useful type conversion functions for the conversions between these data types. Now, let's see how to perform these data type conversions. First, we can use the std logic vector typecast to convert an unsigned data type to a std logic vector data type. Similarly, to convert from std logic vector to the unsigned, we used unsigned typecast. Note that U and V in these brackets here, these are the signal name where these conversions are being made. So in your VHDL code, replace these identifiers with your signal name. So to perform the typecast, we simply write unsigned followed by the signal name in the brackets. So unsigned V means convert signal V, which is a std logic vector type, to an unsigned data type. Similarly, std logic vector U means convert signal U into the std logic vector data type. So it is that simple. Similarly, we have more typecast, like for the conversions between std logic vector and the signed data type. For example, to convert a signal from std logic vector to the signed, we use signed state typecast. And for the reverse conversion, means from signed to the std logic vector, we use std logic vector typecast. Typecasting also allows conversions between the unsigned to a signed data types and signed to the unsigned data types, like with the middle transactions here in this picture. However, always remember that the length of these vector signals must match during the conversions. If the length of these signals are not matched, then you will get the errors in your VHDL designs. So ensure that the length of those signals are identical. For example, if you are converting a signal from unsigned to a std logic vector, the vector length should be matched here. Now let's see how to convert integer data types. To convert from unsigned to integer, we use to underscore integer function. Note that all the integer conversions are handled using the functions. These functions are highlighted in the red boxes here. So the operations without the red boxes here are being handled using the typecasting, and the conversions inside the red boxes are handled using functions. So this is just for your reference to distinguish the typecast operation and type conversion function. So all previous type conversions which we have covered was happening through the typecasting. However, these integer conversions happens through the functions. So we can go from integer to unsigned using to unsigned function. Now, this function takes two parameters. The first parameter is the name of integer signal, like signal name is I here. And the second parameter is the size of unsigned data type. Note that you also need to take care of potential overflow. If the unsigned vector is not large enough to hold the integer value, then it can cause your overflow. We have similar function for integer to the signed conversions. Again, there is a possibility of overflow when you convert an integer to a signed data type, like if the signal does not have enough bits to hold the integer value. Similarly, you can use to integer function from converting the signed or unsigned data type to the integer data type, and it has only one parameter as input, which is a signal name, which you want to convert into the integer. These conversion functions are available through the numeric underscore std package in IEEE library. So this is a valuable resource for your VHDL designs. This map summarizes the conversion paths between different data types. So try to keep this handy when you're using them. It will always helpful for your quick reference to avoid error. So just take a screenshot of this for your future references. Now let's quickly see how you can write your own type conversion functions. Here is a quick example. We will write a function which will convert a boolean type signal to a std logic signal. Simple. Means this function takes a boolean signal called a and returns the corresponding std logic value. So inside the function, we have written a simple if condition to check the value of a. If a is true, the function will return logical 1, and if a is false, then it will return logical 0. So this is our simple VHDL code for this function. Function to underscore std logic a colon in boolean return std logic is begin if a then return 1 semicolon else return 0, and if and function. So this function is taking a boolean signal called a and convert it into a std logic output. This is a very simple example just to give you some overview of it. So you can call this function now in your VHDL designs whenever it is needed, like you have seen in the previous slide. It is as simple as that. So that's it for today. But before concluding, here is a very important note that these type conversions does not consume any FPGA resources because these functions guide the compiler that how to interpret various signals in your VHDL code. I hope now you have the basic understanding of type conversions in VHDL and now you are aware how to use them. If needed, you can create your own functions as well for different type conversions. In the next session, we will be covering others keyword, which can be used at different places in VHDL and having different use cases. Depends on where this keyword is being used. So it is quite important to understand its proper use cases. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.